It's Miss Billman, and we're at the 5-10 homework. We're looking at the relationships between numbers. And there are different ways that you can show this with an expression or an equation, really, a table, or maybe you like to model it with a diagram. Either way, we're doing it during this homework. So Maria and Juan are sister and brother. Maria is 2 years older than Juan. This is sounding familiar from my own personal experience, but I guess I would be the one. I am the youngest. So we have to look at the two variables. We have M and J. So the M obviously is Maria's age in years, and the J will be Juan's age in years. It's really important to identify your variables before you get started so you really know what you're working with. If you don't, then you're going to kind of be in a world of hurt trying to figure out, oh my gosh, what am I doing? But we've already figured this out. So I have a table, remember, we're going to start with that. So when Juan is 1, Maria is 3, because there's a 2-year difference. When Juan is 2, Maria is 4. When Juan is 3, Maria is 5. When Juan is 4, Maria would be 6. So let's say Juan is 16. Well, she'd be 18. When Juan is 20, Maria would be 22. And when Juan is 100 years old, Maria would be 102. I mean, I could put any number in there. When we diagram it, I'm going to just draw two different ones. So there's 2 blocks. And when I have my other one, I'm going to draw the bottom. So if I added those together, I would get the age of Maria, because I'd have this 2 plus whatever Juan is at the time. So I would just keep adding on to that. I would keep adding on to that. And you could see that if I put 2 blocks at the M and 1 block with the J, I would have a 4 to 2, which is what we'd be looking for. I could also do J plus 2. So with an equation, Maria's age is J plus 2, and Juan's age is Maria's age minus 2 years. So we're going to write the expression that matches the description. So subtracting x from 4. We're taking away x from 4. The x should come second. Multiply 3 times p and then add 10 to the result. So 3p plus 10. I don't know what p is, but that's as far as it can go. Divide 12 by the sum of x and 9. So I'm dividing 12. So 12 divided by the sum, that's addition, of x and 9. I'm going to try to make that look like a real 9 instead of an 8. So subtract 7 from s, so s minus 7, and multiply the result by 6. Well, that works for me. And I can put parentheses on there if I want. Now we're going to apply the distributive property to all or part of the expression. I distribute the d to the d and I get d squared. And the d to the 1 is just d. So d squared minus d. Now 6, I don't know why I'm skipping a, but it works. 6 to 6m is 36m minus 42, because that is 7 times 6. Now, looking at number 11, I'll just keep going down the column. I'm going to combine like terms, and this would be 3 plus 7y plus 5y, which is 12y, and I could write that, 3 plus 12y. I mean, I'm putting them together. These are combining like terms, the 5y and the 7y. I could also find a common factor, which is 3. I could pull that out and I could rewrite it as 3 multiplied by 1 plus 4y. Because if I were to distribute that again, I would get 3 plus 12y. Kind of crazy, right? Math has so many options. My greatest common factor is 5. So 5 multiplied 3x, that's 5 times 3 equals 15, plus 2 would be 10. So again, 5 times 3 equals 15x, plus 10, which is my original equation that I had. For number 10, I will distribute the 4 to the a and the 3, so 4a plus 12 plus c. I can't really do anything with the c, I'm just adding it, so it stays as is. So again, 4a plus 12 plus c. And number 12, 2x plus x squared. So things they have in common, it's the letter x, right? So 2x is 2 times x, and 3x squared is 3x times x. So once I take that x out, like I take that out, I'm left with 2 plus 3x. If I redistribute that, I would get the same thing, 2x plus 3x squared.